This demo is for TurboPK's parallel grid tool. A parallel grid is a grid of shot lines, one per projectile or fragment, projected straight into the target. So let's select grids and parallel shot line grid. And we're going to do a 45-45 angle. So what we'd like to do here first is show you the clean target at that angle. We'll change this to 45-45. Now the tool on the left would actually set this angle for us in the screen as soon as we activate that angle, as soon as we apply this tool. But I wanted to show what the clean target looks like. So the spacing is 1 inch. It means every shot line will be an inch apart. It's X and Y grid screen coordinates. And there are a number of options under a calculation option. The first one is impact speed on first vulnerable component, which shows you the speed that the projectile, in this case, hits the vulnerable component at. Now the scale on the right ranges from the projectile speed to 0. So the next option down is shot line vulnogram, which is a fairly standard tool to show you what the probability of kill given a single hit is. Now you can see that the red components are closer to 1.0 pk, which for crew members you would expect. And we're going to reduce the size of the grid to pick up some of the smaller components, for example, like the ones we're pointing at here, small thin components. You can see the response time is still pretty fast, and we can get pretty good resolution, even going down to a 1/4 inch or even finer. Now let's see the effect of reducing the projectile speed to 2,000 feet per second. And as you might expect, there are fewer kills, or lower overall probability of kill. Now the next tool down is add-on armor, which allows you to estimate the amount of armor that would be required to slow the projectile down to the point where it hits a vulnerable component with a 0 speed. Now, the scale on the right ranges from the max RA addition inches value of 2 down to 0. Let's increase the speed, and as you'd expect, we need more armor to slow that projectile down. We're going to increase it some more, and you need even more armor. So this tool calculates the thickness of the armor and then estimates for you in this message bar the overall weight that would be, additional weight that would be required to stop the projectiles from an attack in this direction. Now let's change the scale a little bit, or a lot. Change it to 1 inch. And you can see some of the shot lines have turned black, which indicates that they can't be stopped by maximum armor thickness added of 1 inch. So the next tool is first impact obliquity, which is simply a function of the angle of attack and the target geometry, ranging from 0 to 90 degrees. The next option is another function of the geometry, line of sight thickness, modified by the thickness factor. The next option is first impact residual speed, the speed of the projectile after the first impact. And then we'll do the first impact residual mass. And that concludes this example.